When that oil light comes on, you're jumping to conclusions if you immediately say the car needs a new oil pump. Maybe so, maybe no. That light does indicate there's something wrong with the oil system and that the engine could be running on the edge of catastrophic failure for any one of a number of reasons. In this time of self-service gas stations, many people don't check their oil, and some engines have been known to have the wrong dipsticks. The oil pressure sending unit may not be functioning properly, thereby giving a false reading. If the test gauge shows normal pressure, according to the OE specs for the car, you know the problem is in the sending unit or related wiring. But if your test gauge confirms the low pressure situation, you should drop the pan and check the oil system with a bearing leak detector attached at the sending unit opening. With the system pressurized, you can check the bearings for runoff. 60 drops per minute is considered average. If the drip rate is okay, the bearing should be okay. A large or steady stream indicates wear and the need for replacement. Before condemning a bearing, rotate the crankshaft a half revolution and check again. If you find excessive runoff, just replacing the pump may raise the pressure enough to put the light out. But the wear will still be present, and down the road, when the engine wipes out, your customer may blame the new pump and you. If all main, rod, and cam bearings indicate normal oil runoff, replacing the pump may take care of the low pressure problem. But first, check the bottom of the oil pan. Foreign particles indicate worn or damaged engine parts, or a previous sloppy repair job. This debris can damage or destroy the oil pump. There are 3 different oil pump designs in common use. All are positive displacement pumps that should last for the life of the engine, if properly installed, if not forced to operate in a highly contaminated environment, and if not the victims of other part failures. The oil pump must provide adequate pressure and volume to move the oil through the lubrication system. Most engines have what is called a full flow filtration system. Oil from the crankcase is picked up through a filter screen. The faster the pump turns, the greater the volume and pressure. So a pressure regulating valve designed to open at the maximum desirable pressure allows some oil to bleed off and return to the crankcase. The pressurized oil goes through the oil filter, and the filtered oil is sent through gallery openings in the engine block to the moving engine parts. From these, the oil drips back into the pan. When you consider that an engine with about 5 quarts oil capacity may pump as much as 30 quarts a minute through the lubrication system, you can realize how rapid and constant this oil flow must be. Adequate pressure is needed to force oil to the moving parts with sufficient volume to ensure a flow of lubricant throughout the entire engine. Both are dramatically affected by the amount of runoff from the clearances between engine parts. That is why excessive bearing clearance can increase the flow beyond the capacity of the pump and cause pressure to drop. The filtration system is designed with circulating oil as its first priority and filtering as its second priority. If flow through the filter becomes restricted, a relief valve in the filter or filter housing opens, allowing unfiltered oil to bypass directly to the engine galleries. Unfiltered oil makes engines susceptible to premature failure through foreign material entering close tolerance areas. So it's imperative that oil filters be clean and unrestricted for maximum protection. The pickup screen also has a bypass valve. The bypass valve opening usually seals against the surface of a metal shroud or cross strap. But on cold starts, when the oil is too thick to pass easily through the screen, or at high engine RPMs when the pump is circulating maximum volume, the bypass may open. And of course, if the screen is plugged, the bypass will stay open whenever the engine is running. As oil rushes through the bypass valve, a vortex may be created in the oil pan. The vortex can pick up debris, either in suspension in the oil or lying on the bottom of the pan, and pull it into the pump. Even though the pump lives in oil and is as resistant to wear as any part in the engine, dirt or debris getting through the bypass can cause trouble. For those who find it hard to believe that large particles can get past the pickup screen into the pump, witness our collection of horror stories. This pump locked up because it picked up a snap ring, which was forced from a hydraulic lifter due to excessive valve lash. Of course, when a pump seizes, the intermediate or drive shaft is twisted off or sheared. A piece of an aging valve stem seal took care of this pump. A check on the valve stem seals revealed that they all were deteriorating. The pump was the victim, not the cause. This pump points the finger at the guy who replaced the rocker cover gaskets, then flunked on thorough cleanup. Scraped gasket material got into the pan and was sucked into the pump. A small piece of wire from a brush jammed between the rotors of this pump and caused seizure. You can be sure that if the intermediate shaft or the drive slot in the pump shaft is broken, debris caused the pump to lock up at least momentarily. Such seizures can also strip the gear at the camshaft or distributor oil pump drive. Nylon from timing sprockets can break loose and jam the rotors. Scoring or deep scratches prove that abrasives were circulating in the engine oil, probably because the oil and filter were not changed at proper intervals. Or it could mean that abrasives were entering the engine through the air intake or crankcase ventilation systems. This replacement pump didn't last long because the installer, when attaching the pickup screen, clamped the pump body in his vise rather than clamping the shaft housing area. How do we know this? He distorted the housing, causing interference between the inside surface and the rotor. Another replacement goof. The installer cut slots with a hacksaw to make it easier to attach the pickup screen, probably in an effort to salvage an old screen. His modification caused an air leak. An air leak on the suction side of the pump allows air bubbles to enter the system. Air bubbles can cause aeration of the oil, leading to foaming, marginal lubrication, hydraulic lifter noise, and parts failure. This kind of leakage can be caused by trying to weld or braze a loose fit. We are trying to prove several things with this horror collection. First, that oil pump failures are rarely the fault of the pump itself. Second, that examining the inside of the old pump will usually give you clues to what actually caused the failure. Also, examination of the oil pan. Debris often tells its own story. Third, don't put on a new pump without correcting other problems. It should be a matter of good sense and professional pride to protect your customer's investment in the new pump. You are also capitalizing on the most mutually beneficial opportunity for additional profitable service work. Failing to make necessary repairs is sending the cart down the road to an inevitable wipeout of your good work, blame from your customer, and probable loss of service business to a competitor. After you have corrected any possible cause of pump failure, you can install our replacement oil pumps with complete confidence. Each pump is thoroughly inspected and tested for volume and pressure before leaving the factory to specifications at least equal to the original equipment standards for those which they are designed to replace. We recommend installing a new screen with the new pump, and use the proper tool to get a good press fit without squeezing, bending, or rough handling. It's all right to use Loctite or epoxy. Brazing or welding is not recommended. Prime the pump. Turn the shaft and make sure that all internal surfaces are covered with oil. When installing the pump, it's important that the intermediate shaft is properly engaged. You can crack some pumps that fit into recesses if they're not properly positioned. One hand should hold the pump steady, while the other puts in the bolts finger tight. On engines where there is a possibility of crankshaft interference, check the clearance before torquing. The bolts should be torqued to the engine manufacturer's specification. After filling the crankcase, but before starting the engine, Use your pressure tank to prime the oil system. Remember, oil pumps are usually the victims rather than the cause of oil system problems. Good engine service requires pinpointing and eliminating the true cause of pump failure.